Everyone able to see my screen, right? You are able to see my screen and hear the audio, right? Tone.
Yes.
Yeah. Everyone just visit kahoot.it. Okay. Kahoot.it and join the game. Everyone do it fast. Game pin 5728836. Everyone join immediately. Everyone join the game pin. Just visit kahoot.it and type the game pin. Okay. Just you need to visit the website kahoot.it and then enter the game pin. Click on enter. And here you need to type the name. Click on OK Go. That's it. Kahoot.it. Everyone. Fast. I need total 8 participants. I need total 8 people. I think, yeah, total 7. I need 7 people to be present here. Everyone. I'll give you just 2 minutes of time. Everyone join. Everyone join fast. I am locking the game. Still, if anyone trying to join, just join or else I will lock it. Okay, I'm giving you just 1 minute of time. After that, I will lock it. No one will be able to join. Last 1 minute time. So first question on your screen. What polymer backbone does FR4 use? What polymer backbone does FR4 use? It uses epoxy network. We discussed in the yesterday's session. So Nihal is in the first position, and then Sri Krishna. Rest other people not answered even, or else maybe answered incorrectly. Which monomer builds FR4 aromatic core? A. Bisphenol A, B. Phenol formaldehyde, C. Bisphenol F, and D. Styrene. A. Bisphenol A, B. Phenol formaldehyde, C. Bisphenol F, and D. Styrene. Nihal is in the top, and Dinamal came into third position. Where are bromine atoms located in FR4? A. Alcohol oxygen, B. Aromatic rings, C. Epoxide carbons, D. Methane bridge. Where are bromine atoms located in FR4? A. Alcohol oxygen, B. Aromatic rings, C. Epoxide carbon, and D. Methane bridge. How does bromination affect flammability? How does bromination affect flammability? So A increases smoke, B adds conductivity, C rises fuel load, and D reduces flammability. Which network motif best describes cured epoxy? A. Ionic gel, B. Cross-linked thermoset, C. Linear thermoplastic, D. Crystalline lattice. Which network motif best describes cured epoxy? Which ring structure is central in FR4? Which ring structure is central in FR4? A. Furan rings, B. Cyclohexane chairs, C. Pyridine ring, D. Phenyl rings. Option D is correct. Which atoms form the ether bridges? Which atoms form the ether bridges? A. Silicon and carbon, B. Nitrogen and sulfur, C. Oxygen and carbon, D. Sodium and oxygen. We know ether means ROR, carbon and oxygen. Nihal and Vaibhav is also growing, and Sri Krishna is on second position. So complete the sentence. Bromine is bonded to dash rings. A. Saturated rings. B. Heterocyclic aza. C. Aliphatic cyclo. D. Aromatic phenyl. Very simple question. Just from the structure of FR4. If you just check the structure, you will get the answer. Yeah, it is aromatic phenyl. So we are having the scoreboard. Sri Krishna has the highest answer. Which sites become secondary alcohols? A. Methyl carbons. B. Epoxide carbons. C. Carbonyl carbons. D. Brominated carbons. So no one selected correct answer. It is epoxide carbons. So leaderboard, please, computer. Yeah, still same. Next question on your screens. True or false type? Double points. If you answer, you'll get double point. Brominated FR4 contains an epoxy group. Brominated FR4 contains an epoxy group. True or false? Brominated FR4 contains an epoxy group. Is it true or false? Yeah, time out. So it is true. Again, leaderboard, please, computer. Yeah, Inamal and Vishal, better luck next time. So this time podium is filled with, so third rank goes to Vaibhav and second rank goes to Nihal and first rank goes to Sri Krishna. Better luck next time, guys. Yeah. So welcome back to today's session. Okay. So now we'll be discussing about bias, types of bias. Okay. Now we'll be discussing about types of bias. There are basically uh, these are actually called as bias. Okay. They are also called as drill holes. Okay, drills. As you can see, these are actually called as drill holes or else bias holes basically. Okay. This is called as plated through hole and this is called as non-plated through hole. The difference is that in plated through hole, you can find this copper lining. Okay. So plated through hole, vias are lined with a conductive material, which allows the signal transmission. This is the plated through hole. And these non-plated through holes are basically, they are just for mechanical purposes. Okay. For fitting the screws. Okay. But, or else for mounting. okay, or aligning the PCBs, mechanical purposes, but it does not carry any kind of electrical conductivity. It is lacking electrical conductivity. Whereas this plated through hole, it is having the electrical conductivity. It allows the signal transmission because it is lined with the conductive material. These non-plated through holes, these are uh, not not lined with any conductive material, so therefore it is lacking of electrical connectivity. Whenever there's electrical connectivity, then only signal transmission is possible. Without conductive region, no signal transmissions cannot occur. Okay. So basically, we are having different kinds of drill holes. The first one is plated through hole, which we discussed right now, which is having a conductive material lined with it. And this is the non-plated through hole, which lacks the conductive lining and therefore no electrical conductivity, lack of electrical conductivity. So no signal transmission occurs through non-plated through hole. Okay, so this is based on one classification. Okay, and there's one more classification. According to that, there are three main types. Okay, as of now, we are discussing about two main things: blind bias and buried bias. Okay, or buried. So blind bias and buried bias. Some people call it as buried bias, but actually its pronunciation is buried bias. Okay. Yeah. Coming to this particular thing, in blind bias, the definition states that it connects outer layers to one or more inner layer, but do not pass through the entire board. These blind bias do not pass through the entire boards. This is very important. It do not pass through the entire board. It is, we are in PCB is made up of multiple layers, right? PCB is, right now we are working on single layer or double layer. But there are multiple, PCB can be multi-layered. It can have 3 layers or 4 layers or even more layers. So in multi-layered PCB, if you want to pass some connections from the upper layer to the bottom layer, or else maybe you want to do some connections to be passed from one layer to another layer, then you will be taking help of blind wires. These blind wires do not pass through the entire PCB. Okay, it passes through specific PCBs. I mean, sorry, specific layers wherever there's a requirement of it. Okay, and next comes buried wires. These buried wires connects only inner layers, remaining invisible from board's exterior. Let's say these blind wires, let's say, uh, they appear from the outer surface. If you just look from outer surface, these blind wires are visible. Blind wires can be either plated or it can be non-plated. Okay, usually it's plated because we are using wires means then there's a assumption that some signal needs to be transmitted among the layers. Okay, so these blind wires do not pass through the entire PCB. It starts from the exterior external layer. It starts from the external layer and it goes uh, deep into the inner layers. Not necessarily that it should pass through the entire PCB. There is no such a necessity. Okay, but these buried wires, so for 100% sure, it is not visible from the external layers. So that means these wires present in the internal layers. So for outside, the PCB is flat, no hole appears from the outside. Okay, so that's why it is called as buried. That means only internal, it is present only internally, does not appear visually from the external layers, remains invisible. Okay, but this blind bias is visible from the external layers, so it not necessarily it should pass through the entire board. There is no such necessity. Yeah, so I'll show you the images. So this is the through hole via. Okay, this is the through hole. Through hole means it passes through the entire board. Okay, through hole means it passes through the entire board. So these through hole wires can be of two types. Okay, one is plated through hole and another one is non-plated through hole. Okay, of course, these blind wire, buried wire, these are made up of a conductive. They have a conductive region lining. Okay, and these plated, in plated through hole wire, we are having conductive lining. So the if there's a presence of conductive lining means signal transmissions can occur. Okay, and coming to the another one, non-plated through hole via, which is there for just mechanical purposes, just like for mounting or else inserting screw for screw fitting. For that purpose, non-plated through hole vias are used. Coming to these blind via, So this blind via, see, it is beginning, it is starting from the origin is from the external layer. It is going into deeper into the layers. This is a multi-layered PCB. Okay, it's something like a tri-layered PCB. Okay, uh, it is going deeper into the inner layers. It is connecting few connections from the upper layer to the inner layer, middlemost layer. But not necessarily that it should pass through the entire board. There is no such necessity. So it can, if it want to pass, it can pass. But usually blind bias means whatever the layer, if it does not, if it passes through the entire board, then it is called as through hole via, right? Because it is passing through the entire board. So if it does not pass through the entire board, then it is called as blind via. Okay. And blind wires also have a conductive region, conductive lining, because it needs to transmit some signals, right? But the important thing that we need to observe, the important observation, notable observation among between uh, blind via and the buried via is that blind via, it is visible from the external layer. This is the topmost layer. It is visible from the external layer. But this buried via is invisible. It is present just internally. It is not visible externally. So such kind of vias are called as buried via. This is also a blind via. It started at the bottom layer and it is going into the deeper layers, and it is ended maybe at some point of layer. Okay, not necessarily it is passing through the entire board. If it passes through the entire board, then it is called as through hole via, which can be of a plated through hole or non-plated through hole. If it is plated through hole, then signal transmissions can occur. If it is non-plated through hole, then it is lack of electrical conductivity and it is just there for mechanical purposes. So here we are having one more image. This is how vias are, different kinds of vias. So this is the top layer. These are the copper traces. See, these vias are connected to the copper traces. Now we are having some other inner layer. Okay, like that. See, now with the help of internal plane. Okay, see, this via came all the way up to another via over here, and again one more connection is arising over here. Okay, so this is the different kinds of vias, plated through hole. And there is one more thing. This is one classification, and another classification is based on upper shoulder mask. And according to one more classification, there are two more kinds of vias. One is tinted via, and another one is non-tinted. Okay, one is tinted and non-tinted. If you just observe the difference between these two things, so this is called as tinted. The reason is that above these via, you can see shoulder mask, the green color appearance, right? So if the shoulder mask is present on the top of on the upper surface of the via, then it is called as tinted via. Okay, if it is not there, shoulder mask is not there, then it is called as non-tinted. So today we discussed about tinted via, non-tinted via based on the presence of shoulder mask, and then first and foremost, vias and their different kinds like uh, buried via, blind via, through hole via, and in through hole plated via. Uh, Plated through hole via and non-plated through hole via, and their electrical conductivity and their capabilities of signal transmissions. Okay, so tinted via and non-tinted via is the classification based on the presence of shoulder mask. If shoulder mask is present on the top of the via, then it is called as tinted via. On the top of the via, if no shoulder mask is present, then it is non-tinted via. That is one more classification. So there are different images. You can just go through about the vias, different kinds of via. See, this is through hole because it is passing through the entire piece. This is just a diagrammatic representation. Okay. So this is blind because it is originating from the external layer. And this is buried because it is invisible from the external layer. That's how, based on the visibility and how it passes, whether it passes through the entire board or not. So based on that, these three categories, these three different kinds of vias are classified. That is the classification. Are you able to see my screen? Uh, okay. Yeah. So in ECDA, whenever we add any kind of via, so its x and y coordinates are listed out. Okay. And these are that, this is called as something like a drill file. So drill files commonly in, there are different file formats. Okay. So just like Gerber file. So in the Gerber package, Gerber is like a combination. It's like a compiled version. Okay. Of all the compressed format of all the different informations, different files, different IPC related files. We discussed about impedance, right? IPC, different kinds of thing. So similarly, these files are also of different formats. It could be in XLN format, or else it could be of NC drill format. These are two famously used, okay, famous file format for drill files. So simply for your understanding, drill file is something like, it is a file containing the complete information about the drills only. Drills means the about vias. Wherever if you add any kind of via, if you place any pleat, no matter whether you are placing PTH plated through hole via or else NPTH non-plated through hole via, or else you are using a buried via or blind via, right? Or else you are using a tented via, non-tented via. So the complete information about those drill holes, like their coordinates, x and y coordinates, their positioning, all this information is present in something like a tabular form, which is called as a drill file. Okay. So these drill files can be generated in ECEDA. Drill files can be generated in ECEDA. So what a drill table consists of? Drill drawings are the visual representations of data. On the other hand, drill tables consist of information in tabular format. That's what I said. Uh, the entire drill file, it consists of the information which is uh, arranged in a tabular format, which is represented in tabular format. Okay. A drill table lists the size and number of holes for each drill used on the board. Each drill size can be represented by a symbol, a letter, or the actual hole size. When a drill drawing is generated for the board, actual drill site is marked by a symbol as shown in the image below. But this type of tables are not required in Gerber format, hence cannot be seen there. A typical drill table consists of, uh, so this is the, when you just, there would be few tools, okay, available even in the online. When you just upload the drill file, it will automatically generate something of this kind of image, okay, visual representation. Because the drill file is the represent already, it contains the entire information about the sizes, whatever the drill hole that you are placing on a PCB, it's a dimension, it's a size, the diameter, the radius, the positioning, the coordinates, ordinate, abscissa, x and y. Okay, if you assume like a PCB, it's like taking the x-axis and the y-axis and taking some reference point as the origin. So from that, the coordinates of each and every drill hole, the center point of each and every hole would be present in the drill file. So based on that information, we can convert that into an image, a visual representation, an image from the tabular data. We can convert it into an image. That's what being shown over here. So when you just uh, run the 3D model or else a 2D model of a Gerber file, this is how it appear. But when you specifically simulate the drill file, this is how it appears. Okay. See, these are the drill holes, right? Drill hole. This is also one drill hole. Here we are having drill holes. So the same information is present inside the drill file. Okay. So directly when you just simulate the Gerber file, this is how you get an appear, how the PCB is appearing for you. But behind that, there is a rendering engine which actually determines the positioning and the coordinates of the drill holes, and from that it is running. It is showing this visual form. Okay. So behind this, there's a rendering engine which can extract the information from the tabular form present inside the drill file. So this is the drill file. But when you run the 2D simulation, the same, it is combining the positioning. Basically, the different for different things we are having different files, isn't it? For positioning of the components, there is a separate file. For drill holes, a separate file. Footprints, separate file. Symbols, a separate file. But when you just simulate the 2D model of a PCB, all files, the entire information will be integrated with each other, and finally you are getting this something like this kind of PCB in the simulation. But behind that, there are so many files running in the background, which you may not be aware of. Okay, so a typical drill table consists of three main parameters. First one is the size. What's the size of the hole? What's the diameter? Whether what's even in plated, if you are taking a plated through hole via, so for that two main parameters would be there, because plated through hole vias are not only just uh, there for mechanical purposes, it is there for signal transmission, because it is lined with the conductive region, right? Conductive copper region. So that means we are having two different cylindrical shapes. The first one is the actual, because see, if the difference between the non-plated through hole via and the plated through hole via is that both are same actually, but the plated through hole via is having an additional lineup lined up by a conductive region, which is basically copper, right? So then the radius would be there for the conductive copper lining, and the radius would also be there for, if you just assume, if you before placing the conductive copper region, it is equivalent to non plated through hole via, right? That means it is having two radiuses. So we need to also adjust. Yeah, we also need to adjust uh, what's the thickness of the lining, right? So that's why it is having so many parameters. The size of the hole or slot should be after copper plating and final finish are applied, and the quantity, the number of drill hits made at the size. So we will discuss about all these three parameters in the upcoming session in more detail. This is just to introduce drill holes with you. What are the different kinds of drill holes? Just to introduce about these things. But in the upcoming session, we will discuss more in detail with the help of a PPT. What are the different parameters, right? And tolerance. All these parameters will be discussed in the upcoming session. Okay. So this session is just to introduce. Actually, today we need to conduct only the quiz session, but I felt we should introduce. Today I'm just introducing the drill holes with you, types of drill holes. So in the tomorrow's session, we will discuss about in detail about these vias, how the signal transmission is occurring, how to determine the thickness of the inner lining of for the plated through hole via. Okay, yeah. So this is the today's session. So you are having any questions up to here? Any questions, guys, from the previous sessions or today's session? Ibrahim is there, right? Ibrahim, you have any question? Ask something, because in each and every class only you are asking the question. Inamal is there. Ray Krishna, are you able to follow? Okay. So today's session is short and simple. So it's a quiz session. What we learned in the yesterday session, those who attended the previous session, where we discussed the chemical structure of FR4 material, the epoxy resin, bisphenol A, types of bisphenols, bisphenol A, bisphenol S, uh, and we discussed EDCs, endocrine disrupting chemicals. So these BPAs are considered as endocrine disrupting chemicals. So all these things we discussed in the yesterday session, and we discussed about something like BPAF, uh, bisphenyl, uh, um hexafluoroacetone, bisphenyl hexafluoroacetone. How buried vias drills are made? How buried drill as drills are made. Yeah, there's a manufacturing process. I already told you in the introductory session, the course is focusing on how to do these kind of thing in ECEDA. There's a separate special manufacturing process how these buried wires are made. I told you the course is about how to make single layered and it's mostly single layered PCB, and we are giving an introduction to the double layered PCB. Okay, so how buried wires drills are made, for that you need to opt in for a different course. We are having some other courses where we'll be discussing about multi-layered PCB. In multi-layered PCB, we will clear this question. Okay. Yeah. Thank you for joining today's session. This is Hemant, your expert mentor from Suchana, signing off. Bye bye.